I am currently recording. So this is beginning of the appendicular skeleton. That means the beginning of the second half of the skeleton chapter in your book. So let me go to my first whiteboard here and I'll start talking about, first of all, appendicular, that word appendicular comes from the root word appendage. So we're basically talking about the arms and the legs and everything that's involved with those. So let me hit my first whiteboard. So the word appendicular means appendage, and that includes, the appendicular skeleton includes arms, obviously the wrist all the way out to the hands and the fingers, legs, and ankles all the way out to the toes of the feet. But also it includes two things what you and I call the shoulder is the pectoral girdle. That's where I'm going to start today. And the pelvic girdle. So when you see those terms, just think shoulder and hips, or the shoulder joints and hip joints. So let's start with pectoral girdle. Pectoral means the chest region, that upper chest region. And girdle refers to the shape of this joint, although it's not a true girdle shape, to be honest with you. It doesn't connect all the way around. This includes the clavicles, which are the collarbones, and the scapulae. That's plural because there's two. If I write it like this with just an A, that's singular. If I add an E to it, that means more than one. And I'm going to put in parentheses, times two because we have a right and a left. All right, so that's where we're going to start talking about this business of the pectoral girdle or the shoulder. First and foremost, this is the most freely movable joint in the human body. So I'm just going to write most freely movable. Now, that comes at a cost, and I'll discuss that in a moment. But we can move our shoulders almost in a 360-degree rotation. So it is extremely movable, but that also, the cost that comes with it is very unstable as well. So it's injured frequently. What makes up the pectoral girdle is the clavicle or collarbone plus a scapula, and those are the two bracing bones, and the upper arm articulates with that. Let me draw that really quickly. If this is a collarbone, you're looking at the anterior surface. So there's my right shoulder. The scapula has a prominence that comes up like this, and then behind our back, we would see that shoulder blade or scapula like this. And then the head of the humerus articulates with a place on the scapula, the head of the humeral bone, the arm bone, sort of like this. So that's your book listed as two major bones that are involved with this joint, but it also includes the head of the humerus. So we've got the clavicle or collarbone here in front, the scapula or shoulder blade in the back, and then the head of the humerus or upper arm, making up that pectoral girdle. So the mobility factors are due to the fact that the clavicle attaches to the axial skeleton. I'm going to say attaches to the sternum, and technically it's the manubrium of the sternum. And that means this end right here. So here's the sternum. I'm going to draw the manubrium. It's kind of heart-shaped. So we have a ligament attachment right here, and there's a ligament attachment of the distal end of the clavicle to the scapula, but then the scapula, other than that, moves freely. So I'm going to write but scapulae move quite freely. It's a sliding motion, but that's really what allows for all of that motion in the joint, is that the scapula are only articulated with another bone right here. They're not articulated with another bone on our backs. They're just embedded in soft tissue. Tendons of muscles really just grip them. Also, the socket, the ball and socket joint of the humerus head, I'm just blowing up this area right here. The humerus head of the upper arm is attached to a very small socket on the scapula. Some orthopedic surgeons call that a golf ball on a tee because it's so precariously perched there. And that, that shallow connection here, unlike down at the hip where the head of the femur goes into this deep-rooted socket like this, that provides for a lot of stability but takes away motion. This connection point of the humerus to the scapula is really precarious. And so I'm going to say humerus is attached to a very shallow glenoid cavity. Both of these things allow for tons of movement. But like I said, that comes at a very costly investment in that it's very unstable and easily injured. All right, I'm going to talk specifically about the clavicle bone, then the scapula, and then we'll get onto the arm bones, okay? So the clavicle, you know, is the collarbone. We all know about where that's located. It's one of the most easily palpated bones in the human body. We can feel our collarbones. It protrudes right at the base of our neck on either side, left and right. And it's shaped like this. This is a bird's eye view, not from the front, anterior view, but a superior or bird's eye view. The clavicle it's S-shaped. And there's a flattened end out here, and then sort of a trumpet end this way. So this is a top view. The distal end out at the shoulder, so I'm going to write distal. We'll talk about that. And this is the proximal end, which is close to the sternum or the midline of the body. They have different features. This end is flattened, F-L-A-T-T-E-N. That's flattened. The proximal end comes to a 3D trumpet shape almost. The proximal end articulates with the manubrium of the sternum. In those clavicular notches. Let me draw that. That's not a great manubrium. It actually does this. And this is called the clavicular notch. And there are ligaments, which are tough, fibrous, dense connective tissue that makes this bone-to-bone connection here. Out at the distal end, this end of the clavicle bone out here actually articulates with a prominent process on the scapula. And I haven't talked about the scapula yet, but I'm going to write articulates with the acromion. That's the name of the spot on the scapula. And there's also a ligament, bone-to-bone connection, tough fibers connection out there. So we call this the sternal end, and we call this the acromial end, or the lateral distal end is the acromial end because it attaches with this point on the scapula. That's where it gets its name. Now on the clavicle, there's something called a conoid, C-O-N-O-I-D, tubercle. Tubercle just means a small little bump or prominence like this. There's a conoid tubercle on the clavicle at the lateral end for the conoid ligament to attach it to the scapula. To attach clavicle to scapula. And I'm going to put in parentheses, we call that ligament the conoid ligament. So I'll just highlight that in green. So out here, there's a conoid ligament that attaches it to the acromion process on the scapula. Here, this ligament, I'm going to make it red, has a different name. It's just called the costoclavicular ligament. Costo means rib. It's all one word, and I'm going to run out of space here. The costoclavicular ligament. I want you to recognize these names. Attaches the clavicle to the sternum, particularly at the manubrium. So if I ask you at quiz time, so if I say that the conoid ligament, just remember that it's at the lateral or acromion end, and it attaches, it attaches out here to the scapula, out near the shoulder, and the costoclavicular ligament, which I've drawn in red, actually attaches the clavicle bone to the sternum. Let's move on. The scapula, and we have a right and left, so we have two of them. It's a triangular shaped bone that from the back side, if you were viewing this bone from the back, it would look something like this. It's a big triangle with a ridge of bone running diagonally up the middle of its back, the big prominent process on it. And then there's another process behind it. This is roughly what the scapula looks like from a posterior view. I'll identify some of the major features of this bone. First, the medial border, which if this is say the vertebrae of the back here. So this is the midline of the back. This is the shoulder area out here. The medial border of the scapula is somewhat convex. It makes an outward bow. And then the lateral border, which points away from the body, is concave like this. This diagonal ridge of bone, whoops, I didn't mean to do that. This diagonal ridge of bone that I'm redrawing right now is called the scapular spine, and it's just for muscle and tendon ligaments. So we call this the spine. At the end of the scapular spine is a big bulbous protrusion called the acromion. That, if you feel your shoulder right now, the very top of what you call your shoulder, you feel a bony prominence there. This is what you're feeling, is the acromion off of the scapula. That's where, I'm going to go back to my previous picture, that's where this end, the lateral end of the clavicle attaches, is to that acromion of the scapula. There's diagrams in your book that really help with this arrangement and visualizing this arrangement. So some other features of the scapula. There's a spot on the lateral surface that I'm highlighting right here, I'm thickening with my pen, called the glenoid cavity. That's where the head of the humerus articulates. It's hard for me to draw on this glass board with a plastic pen. So if I take all of my words away, let's just erase glenoid cavity for a second, and then I'll put it back up there. That's where the head of the humerus articulates. So I'm going to quickly draw the upper arm bone. There's the head of the humerus. At this articulation point, the head of the humerus articulates with that glenoid cavity. That's the place of most freely movable articulation, but it's also the place where it's very unstable and damaged very easily. What you and I refer to as the rotator cuff is really just a whole series of 5 to 7 muscles that stabilize this joint, that attach from the humerus to points on the scapula, to points on the, so it's a series of muscles that help stabilize this that we refer to as the rotator cuff. A couple more things to mention about the scapula before I move on. There's something called the suprascapular notch. That is a very prominent feature. It's up in this region. Let me see if I can erase just part of my top border. And I'll draw the notch for you now. Supra means above or on top, scapula, notch. So it's just a notch on top of the scapula. So if we do this top border, there's a U-shaped notch right about here on the scapula. And that's for a prominent nerve to travel through there. We're just going over the basic anatomy of these bones that make up the pectoral girdle right now. Finally, the last feature that I'm going to list is called the coronoid process. Hard to see in my drawing. It's difficult to see from that posterior view. This is a back view that you're looking at now of the scapula and the pectoral girdle. So let me go to an anterior view. So if you could see through my chest and see the front of the scapula, it would look something like this. I'm going to draw it going the opposite way. Here's the glenoid cavity. And attached to the base of the glenoid cavity is a second finger-like process like this. There's the suprascapular notch. Here's the lateral border, medial border. The scapular, the back side that we can't see right now, there would be a spine on the back going up diagonally that we drew on the last picture. And then the big sort of prominence at the end of the spine is that acromion. I'm putting them in dotted lines so you don't pay attention to much as them. The acromion is actually where the clavicle attaches right here. But this bent finger-like process is called the coronoid process. And that's basically for soft tissue attachment, tendons and ligaments. So I'm just going to write it's for tendon attachment. So is that scapular spine on the back, by the way. For muscular, tendons are just muscle to bone connections. Ligaments are bone to bone connections, just to remind you of that. So that gives you an idea of what the most prominent features on the scapula. And this whole these whole surfaces are freely movable on our back. It just glides along the back of our ribs without any bone-to-bone articulation. The only bone-to-bone articulation really is this point here on the acromion, and very little attachment along here to the head of the humerus. So that gives us that 360-degree motion. All right, let's go on to the upper limb. So let me layer over this board. Now we're going to talk about the arms all the way out to the tips of the fingers. There's 30 bones total in each limb. So I'm just going to put ×2 for right and left. And that goes like this. We can simply, it's not as complicated as you think. So I'm going to try to draw a really simple arm. There's the humerus. That's one bone. And there's the radius and the ulna. That's 2 bones. There's 1, there's 2. Then there's the wrist bones. And I'm drawing 8 little circles. There's 8 bones in the wrist. I'll go over those in a minute. And then there's 5, they're called carpals, the wrist bone. Then there's 5 metacarpals, which are in the fleshy part of the hand, the palm of the hand, the first set of long bones. And then, so I'm gonna write 5 for metacarpals. And then we have the fingers, including the thumb. And there are 14 phalanges that in the fingers. So it would just be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and only 2 in the thumb. That makes up, and if you add that up, it comes out to 30. This is the humerus. So it's not as complicated as it first looks. This is just the radius and ulna in the forearm. There are 8 carpals. Those are the wrist bones. You don't have to memorize all 8 names. I just want you to I'll tell you what I want you to recognize before we leave. There are 5 metacarpals. Those are the first set of long bones in the palm of the hand. And then 14 phalanges. Obviously, this is on each side, either side, so it's 30 times 2. So if I asked you how many total bones are in each upper limb, the answer is 30. If I said how many total bones are in the upper limbs in the human body, that would be 60. Now let's go through these bones one at a time. We'll start with the humerus. We'll just go down. In order to save space, humerus is spelled H-U-M-E-R-U-S. There's no O in that. Like, it's not funny, haha, humerus. You know what? I am going to go to a new whiteboard because I want to detail this bone as best I can. So here's the head of the humerus. I'm going to shorten it because it's a horizontal board that I'm drawing on. That's the proximal end at the shoulder. And then at the distal end, it makes, this is an anterior view. I'm going to put a circle here and then a V or U-shaped groove and then a big bump sticking out to the side. Let's identify the major features of the humerus. First and foremost, there's a head that articulates with the glenoid cavity of the scapula, and that's easily identified because of its big, round, prominent feature. There's also something called the anatomical neck, which sort of, I'm going to draw a dotted line. That's the anatomy, the anatomical neck. And then there are 2 bony prominences worth mentioning. The first one is here, it's a bony prominence, and the second one is a little bit lower and toward the front, anterior right here. This is the greater tubercle. And this is the lesser tubercle. Given their names because of where they're located, one's higher than the other. The lesser is lower. A tubercle is a small projection coming out of a bone. Those are for, guess what, tendon attachments to that rotator cuff assembly. Then as we move up, there's something also called the surgical neck here, where the bone starts to decrease in diameter. It's called the surgical neck because that is where the humerus is most frequently broken, and oftentimes surgery is needed in order to repair that. Now in the diaphysis of this bone, I drew a very slight bump here so that you could see it. That's called the deltoid tuberosity. And it's where the shoulder muscle inserts. The shoulder muscle is called the deltoid, and it comes down over the shoulder and attaches right there, so that when this muscle contracts, it raises the humerus up away from the midline of the body. Also, there is right next to that radial tuberosity, it's hard to see even on a real bone, but there's a very slight groove. Whoops, I didn't want red. There's a very slight groove right in this area. So I'm just going to label this the radial groove. And it's for the most prominent nerve that runs down the upper arm. So I'm going to write 4. Prominent nerve on the upper arm. That's actually called the radial nerve. That's where the groove gets its name. Now we're going to identify structures down at the distal end. So this is the shoulder end, pectoral girdle, shoulder end, and this is the distal elbow end. I exaggerated this round circle. It doesn't look quite like that in real life. Let's start there. That's called the capitulum. That capitulum articulates with the head of the radius. The 2 bones in the forearm, which I haven't gone over yet, I'll do those next. One of them is called the radius. And this round circle in the humerus at the distal end articulates with the head of the radius bone. Technically, if you're interested, the head of the radius, I'll draw this in a minute, looks like a nail head like this, and it has a slight depression in it. And when we flex our forearm, when we bend our arm at the elbow, this depression rides along this sphere, this marble-like structure. It rides right on the top of it. There's also a radial fossa, which is, fossa means depression or groove, and there's a radial fossa, which is also a groove for the radius right here. Let me highlight that in a different color. So the radial fossa and the capitulum basically serve the same function of accommodating the head of the radius when we flex our forearms. So it articulates with the head of the radius as well, just on the side of the head rather than the top surface of it. Now I did draw, I'll try to color code this to make it easier to see. There's another groove that I attempted to draw right here. I'll highlight it in blue. That's called the trochlea. And the trochlea actually looks like sort of like an hourglass on its side. It's shaped kind of like this, or a bow tie. And this concave area that wraps all the way around the end of the humerus at the elbow. And that accommodates something called the trochlear groove of the ulna. So articulates with, it's called the trochlear notch of the ulna, which is the other bone in the forearm. And finally, I've really exaggerated this one. I'll use yellow. Out here on the end is this very bony prominence on what you and I would call the inside of our elbow. It's the medial side of the humerus, and it's called the medial epicondyle. You can really feel that. If you feel the inside of your elbow right now, that big bony prominence is this. And the medial epicondyle, sometimes we call it the funny bone. The reason it's called the funny bone is because when you whack that on something really hard, you get a nerve sensation. it's really where the, I'm going to put in parentheses, the ulnar nerve runs just underneath the skin, very close to this bone. So is adjacent to the medial epicondyle. That's why we call it, we get that tingling nerve sensation when we bump it on something. So that's the humerus bone. Let's do the radius and the ulna now in the forearm. Get my black pen back. Easy way to remember which is which. Always, the radius is always on the thumb side of the forearm. So if you find, obviously, the base of your thumb on your hand and you run a straight line up from there to your elbow, that's the side of the forearm that your radius is on. The ulna is on the pinky side. So find the outside of your outside pinky and then run a line up your elbow where you feel that prominent elbow point. That's where the ulnar bone is located. So these two bones are actually connected at 3 places together. So the radius and ulna articulate each other. Let me do my best at drawing a radius and ulna first. The radius kind of has a nail head at the top like this. Has a bump coming out, and it actually gets wider as it goes down toward the wrist, the distal end, something like this. That's the radius. The ulna has a very prominent C-shaped claw at the top of it. Kind of looks like this. I've turned it a little bit. It would actually face forward just so you could see that C-shaped claw. And it narrows, it gets smaller in diameter as it goes towards the wrist. It just sort of does the opposite thing. Like this. And these two bones are connected to each other at 3 places. So I'm going to write 3 points of connection. They are technically articulations, even though there's very little movement at these places. 3 points of connection. That's what I'm going to highlight first. They're just called, at the proximal and distal radio-ulnar joints, and I'll draw those in red. There's the proximal and distal radio-ulnar joints. And then in that space in the middle, it's not actually an empty space in life. There's this sheet of connective tissue called the interosseous membrane. Inter means between, osseous just means bone. That also holds those two bones together, but it's a sheet, and so it's somewhat flexible. And when we pronate our hands, so if you have your palm of your hand facing upward at the ceiling and your arm extended outward, and then you turn the palm of your hand downward, that allows the radius and the ulna to cross over. This sheet, interosseous membrane, allows the radius to cross over the ulna and actually make an X shape when we pronate like that. So let's identify a few prominent features on both of these bones, and then we'll move on. The radius has a head, which looks like a nail head. Let me get my black pen back. There's the head of the radius. There is also a constricted neck portion here. I want to highlight this bump underneath the neck. That's called the radial tuberosity. And that is where the biceps brachii, the biceps muscle in the upper arm, tuberosity, that's where it inserts. So there's a, I'm going to write, there's an attachment, insertion, of biceps brachii. It's two eyes, like Hawaii. Biceps brachii muscle. So when that muscle, the biceps contracts, it pulls on the radius and the ulna to some degree too, and raises or flexes our forearm at that hinge joint. There's a radial styloid process down here at the wrist end, at the distal end. Very pointy. And that radial styloid process is for ligament attachment to the carpals, the wrist. I'm just going to write attachments to carpals, which are the wrist bones. It's also an attachment point. Both of these styloid processes down here are attachment points for the brachioradialis muscle, which we will discuss when we do the muscular system in our next unit. The ulna, the prominence of the elbow is right here. It's almost a 90-degree turn. This big, thick prominence on the ulna bone. That's what you and I call our elbow, actually. But it has a scientific name. It's called the olecranon. Right, bony elbow prominence. So what we call the elbow is actually the head of this bone, or this big thick part of the ulnar bone up here. Then this C-shaped claw has distinguishing features as well. I'll highlight those. This top point of the C-shaped claw is called the olecranon process, because it's part of that olecranon. Then there's the trochlear notch, which is this groove. I'll highlight it in yellow so you can see it. That's the trochlear notch, which really articulates with the trochlea groove on the humerus. It's too bad we can't be in person, because I could show you how this really works in person. It's interesting to see how the elbow hinge joint works. And finally, the lower part of this C-shaped claw, I'll highlight that in blue right here, is called the coronoid process. C-O-R-O-N-O-I-D. And what these two processes do, the olecranon process and the coronoid process, when we straighten or flex our arms, these points, they go into fossas or depressions on the humerus. So let me quickly go back to my humerus picture. There is a big space or cavity. There's one on this side, right about here on the humerus. It's not a hole, it's just a depression. And then there's another one on the reverse side as well. The olecranon process is much deeper than the coronoid process. The coronoid process sits on the anterior side. That's the one I've drawn. On the back side, there's an even bigger depression. And when we straighten our arm, when we straighten our arm, this point, this process fits into a fossa on the humerus. And then when we flex our arm, this point fits into its fossa on the other side of the humerus. All right, let's go to carpals, the wrist bones. There are 8 on each arm or each hand. I'm just going to say, let's just say wrist. That's more accurate. these carpals, I'm just going to list the proximal one and the distal one so that you recognize their names. You don't have to, I won't ask you on test day to list all 8 carpals or even identify them from a diagram. Here's what I want you to be able to do, please, is just identify the proximal 4. That means the 4 that are closest to the radius in ulna. That's what proximal means. And they are, by the way, they get these names based on their shape. They are the scaphoid, the lunate, the triquetrum, it's hard to say, it's Triquetrum, and finally the pisiform, Pisiform. So those are the 4 bones. If this is the radius coming down, and here's the ulna coming down that we just drew, we're talking about the 4 carpal bones closest to these, to the 2 forearm bones. Now the distal 4 are closer to the fingers or the hand. So those would be here. And they also get named for their shape. Those are the trapezium, trapezoid, the capitate, and hamate, Hammate. The proximal 4 are here, the distal 4 are here. Distal to the wrist bones, the carpals, there's 8 in each hand, are the metacarpals, which are the first set of long bones, and they're in the palm of the hand. So we've got 5 metacarpals. 1, 2, 3, 4, 5. These are the first set of long bones. And then after that are the phalanges. And the thumb has 2 phalanges, 1, 2. And the fingers have 3, 1, 2, 3. Those phalanges are identified as proximal, middle, and distal based on the one closest to the hand or further away from the hand. So it would go proximal, middle, and distal phalanges. These are also very movable hinge joints, by the way. I'm not going to identify the different parts of the bone for you. We have other important stuff that we need to get to. So just know that there are, let me write this out, 14 phalanges in each hand. There's 5 of these, 14 in each hand, and 8 total carpals in each hand. By the way, carpals are in the wrist next time on Thursday. Tarsals are in the ankle. Students get this confused all the time. I know that you don't have to specifically write answers on these online exams you're taking, but please don't get confused and think. Students do this all the time. Tarpals, that's not a word. That's a mixture between these 2 words. It's carpals and tarsal bones, and they're very specific. So I'm going to say a few things about the pelvis, and then I'm going to end it here. Let's go to the pelvic girdle. The pelvic bones, and I'll go through all of these individually, are also called coxal bones. There's 3 pelvic bones on each side, meaning right and left. And they meet right on the anterior prominence at the pubic symphysis. So let me draw a pelvis for you really quickly. This is an anterior view from the front, okay? So I'll identify the bones. The individual bones. This is a whole pelvis, by the way. Here's the sacrum with the coccyx, the tailbone. And then what comes forward is this sort of ring, this prominence like this, coming towards you more forward. There's a bit of fibrocartilage called the pubic symphysis, whereas the articulation in front, it makes kind of a bowl-like structure, the pelvis. And here's the actual front ridge of that lip or rim of that bowl that I'm drawing now. And then underneath, sort of behind, here's the socket for the head of the femur on the lateral surface here. And there's a portion that hangs down, comes up to the pubic symphysis, hangs down, and comes up. And there's a big hole. In life, there's a membrane in there. So it's, but when we look at the bones in the lab, there's 2 big holes right here. That's an entire articulated pelvis viewed from the front, okay? There are 3, I'll try to highlight the 3 bones on each side. The ilium, I-L-I-U-M, makes up this part, roughly this part of the pelvis. It's the largest bone of the 3 bones. So there's an ilium, and it's very ear-like or elephant ear-like in this area. It's a big flap of bone. The ischium is most of it includes part of this socket, and it hangs down here. This is what we call the ischium. That's what we sit on. So I'm sitting in a chair right now. I'm sure you are too. You're sitting on this lower part of the ischium right here on both sides. And the pubis, let's use red. The pubis juts forward. So this red part that I'm drawing right now, imagine it coming forward towards you at this blue piece of cartilage called the pubic symphysis. And the other side also it juts forward. That's roughly how these bones are, and it would include this little lip of bone here and here. So those are the 3 bones. Mostly look at what's on your left, because when we describe the pelvis and these 3 bones that are fused, there's 3 on each side. Ilium, ischium, and pubis. And then they join at the back here to the sacrum. So let me write sacrum. And this would be the coccyx, the tailbone. So when I say the word ilium, or spell it I-L-I-U-M, I'm referring to what's that bone that's in yellow. Then when we move on to ischium, it's the bone that's in green, and pubis, the bone that's in red. These are unfused at birth. They are not completely fused together. And they stay unfused through our growth period, our physical growth period. They fully fuse at roughly age 22 or 23 years of age. So when we're full adults and done growing. When we look at the pelvis in a fully grown adult, you can't see, I can't see, we can't see the fusion points of 3 bones. It looks like all one big bone, but originally they were 3 separate bones during childhood. I'm going to stop there today. So let me cut my recording and I'll finish up this chapter on Thursday.